Okay, so as I said earlier, we will start our next part from slide number 10. Now, up to slide number 10, what we have assumed is that there is a single product that we need to make, and there is a single kind of a machine that is needed to make that product. Now, as you will see in the next example, and as you see on this slide, the real world is far more complex than that, and we will add a little bit of that complexity into our calculations as well. So what we will be doing now is an approximation of real life, and we will consider a scenario that what if multiple products are made using the same machine or using the same resource. Because if you remember, if I go back in our example, which we did, we just assumed that there is a single product or there's demand for a single product that we have to make, and that product takes 2 hours. Now, from slide 10 onwards, we will assume that there are multiple products that are made. So multiple products. And if there are multiple products being made, then how do we estimate how many machines do we need? And there is a small difference between use of single product and use of multiple products using the same machines. And so let's start. The best way to understand this slide and this equation is through using an example, which starts from slide 11, and that is exactly what we will go through in detail. So in this example, we've been asked to put together a capacity plan for critical operation at this sandal company. The capacity measure is number of machines, which is similar to what we were doing earlier. We have to find out how many machines do we need. Now, this company itself makes 3 different kind of products. They make men's sandals, they make women's sandals, and they make children's sandals. The times needed for each of these products is provided in this table. And the demand forecasts are also provided in this table. So the firm operates 2 8-hour shifts, 5 days a week, 50 weeks per year. Experience shows that a capacity quotient of 5% is sufficient. Now, this is the detail that we have been given in this problem. Now, let's first take the example of men's sandals. So basically, as highlighted over here, we have 3 different products that are made in this company. Number 1, we have the men's sandals. Number 2, we have the women's sandals. And number 3, we have the children's sandals. Now, for men's sandals, it takes 0.05 hours to make a single pair of men's sandals. Similarly, it takes 0.1 hours to make a single pair of women's sandals. Now, 0.1 hours is 6 minutes, 0.05 hours is 3 minutes. And to make a pair of children's sandals, it takes 0.02 hours. Now, these are the processing times that are given to us. What we are also given is setup time, lot size, and demand. Now, demand for men's sandals is 80,000 pairs per year. So basically, we have to make 80,000 pairs of men's sandals. Demand for women's sandals is 60,000. Demand for children's sandals is 120,000. Now, this is the processing time, P, and demand is something which is similar to the example that we just did. The difference in this one is the setup time and the lot size. Now, what exactly is setup time? What do we mean by lot size? Now, setup time, as the name indicates, is the amount of time it needs, the amount of time the machine needs to be set up for this product. And lot size typically is the amount or the quantity of a product that you make. So to explain this, I'll again move to our whiteboard. Okay, so basically to understand this, it's better to think of these 3 products as, I'll just call them, let me first activate the pen. Okay. So I'll just call men's product as A, product A, women as B, and children as C. Now, imagine that you have to make all these three products, A, B, and C, on a single machine. Now, hypothetically, what would happen is that you would first, okay, this is not good. Okay, let me erase it because I'm not. Okay, and let's shift here. Okay, so basically, hypothetically speaking, what would happen is that you would first make product A, right? Now, after you're done with product A, you will have to start making product B. However, what would happen is that since A and B are two different products, men's sandals and women's sandals, you need to set up the machine to make B, right? You just can't start making B on the product B on the same machine, because you have to first set the machine up to make product B. And this time that you invest in setting up the machine is called setup time. So you'll make some women's sandals, and then once you're done with the sandals that that you need to make, then you need to again set the machine up for product C. So again, you will lose some time, which is called setup time. So in essence, you will set up the machine for product C, and then you would start making product C. And then after C, obviously, it will be A again. So again, there is some setup time, and so on, right? So this will keep on going like this. Now, since we lose this time for setting up the machine for these products, we have to account this loss of time in our calculations for how many machines do we need. And that is essentially what we will do in this example. So basically, if I go back over here, it says that the setup time for men's sandal is 0.5 hours, the setup time for women's sandal is 2.2 hours, and the setup time for children's sandal is 3.8 hours. When we are making children's sandals, we always make them in quantity of 360. So lot size means that when you're making these products, how many of them do you make? So we make 360 of children's sandals, we make 180 of women's sandals, and we make 240 of men's sandals. So in other words, basically we make 240 of men, 180, 180 of women's sandals, and 360 of children's sandals. And this time that we lose in terms of setting the machine, so over here between A and B, we are setting up the machine for B. So here it says the setup time for B is 2.2 hours. So this time is 2.2 hours. And for children's sandals, it is 3.8 hours. So this time over here is 3.8 hours. And for men's sandals, it is 0.5 hours. So 0.5 hours over here, right? So as you can see, now the scenario is significantly different from what we were doing earlier. Earlier, the assumption was that we will just make one product using one machine, and we'll just keep on making it. Now, since there are multiple products being made on the same kind of machine, we need to account for this setup time. So how do you do it? In essence, the logic is very similar, but the application is slightly different. So let's start with product A, or let's start with men's sandals. So I'm going to write it here, men's sandals. Now, similar to what we did earlier, how much time do we need to fulfill the demand for men's sandals is given as T times P, right? Which is we need to make 80,000 pairs of men's sandals, right? So that is the demand. We need to make 80,000 pairs of men's sandals. Each pair takes 0.05 hours times 0.05. Now, these are the number of hours we need to make this product. And I think I have a calculator here. It's 80,000 times 0.05. Let's do that. So we have 80,000 times 0.05, and this is 4,000 hours. So 4,000 hours. Now, in essence, what we are saying is that in order to fulfill the demand of 80,000 pairs of men's sandals, we need 4,000 machine hours, right? However, this is not the only time that is needed for men's sandals. The other time that we need is the amount of time we spend setting up the machine for product A, right? So we not only have to estimate how much time do we need to make the product, which is making the product. We also need to estimate the time to set up the machine to make this product, right? So I'll write here, this is time to make, and this is time to set up. Now, how do we estimate how much time do we need to set it up? We need to find out how many setups do we need times time per setup, right? So if you know how much time do we generally spend setting up the machine for product A times how many setups are required, we will have the answer of how much total time is needed to set up the machine. Now, time per setup is something that we already have, right? If I go here, it says that whenever we set up the machine for product A, it takes us 0.5 hours, right? So that is the setup time. So we already have time per setup, which is 0.5 hours. Now, what we don't know is how many setups do we really need? And that this number is given to us by this equation, which is T over Q, which in this scenario is the demand for our product is 80,000. And Q, which is the lot size, is 240. And in a minute, I'm going to explain the logic of why is this D by Q. But let's first do the calculations, and then we will come back to this explanation of why does this ratio of D over Q gives us how many setups do we need. So let's just first do this calculation. So again, I'll go to the calculator. We have, I'm going to clear it. We have 80,000 times 0.5, which is basically 40,000, divided by 240, which is 166.67 hours. So let me write this here. 166.67 hours. Now, essentially what this number is showing is how much time do we need to spend in total to set up the machine for product A when we have to make 80,000 pairs, right? Now, so the total time that is needed to fulfill the demand for product A, which in this case is men's sandals, is time to make, right? Total time to make the product plus total time to set up the machine for making the product. So time to make, as we just estimated, is 4,000. So we need 4,000 hours to make 80,000 pairs of men's sandals, and the time to set up is 166.67. So this, as you can see, will come out to be 4166.67 hours. Now, the question which I said I'll come back to is, how do we know that D over Q is equal to the number of setups do we need? So the logic for that is that if we go back to our slide, the logic over here is that if we have to make 80,000 pairs of men's sandals, and whenever we are making men's sandals or product A on the machine, we make them in quantities of 240. The total number of setups will be this number divided by this number. Because whenever we make product A, we make them in quantities of 240. Now, basically what would happen is we'll make 240, then we'll make some other product, then we'll again make 240, then we'll make some other product. And we'll keep on adding 240, 240 till we reach 80,000. So in essence, the number of times we make this product is equal to the number of times we will be setting up the machine for this product. And that is why 80,000 divided by 240 gives us the number of setups needed to make this product. And that is why we are using D by Q as a ratio of the total demand divided by the lot size. And this ratio gives us the number of setups needed. Now, essentially what we have done is we have now found out that in order to fulfill the demand for product A, we need a total of 4166.67 hours. We need to do the same thing for our second product and for our third product. And then we will just add all the times together, and that will give us the total time needed to fulfill the demand for A and B and C. And that is essentially what we have done in the very next slide. So if I move on to the next slide, and I'm going to come back to this in a minute. But essentially, if you look here, that is exactly what is being done. So basically, the estimate for number of machines is the time required to make the first product, which is the time required to make the product plus the time required to set up the machine to make the product. So this is 80,000 times 0.05 plus 80,000 divided by 240 times 0.5. That is essentially what we have done here. 80,000 times 0.05, 80,000 times 0.05 plus 80,000 divided by 240 times 0.5. 80,000 divided by 240 times 0.5. So again, time needed to make the product and time needed to set up the machine to make the product. And then, so this takes care of our first one. And now let me just change the colors if I can. And yes. So then essentially we repeat the same thing for the second product, which is women's sandals. Again, it has two different parts. The time needed to make the product and the time needed to set up the machine to make the product. So essentially it is 60,000, which is the demand for women's sandals. And that is something that we can see in the previous slide. 60,000 is the demand times 0.1. That is the time needed to make the product. So again, I'll go here. 6,000 times 0.1 plus D divided by Q. So the demand. So the total women's sandals that you have to make divided by the lot size times the setup time. That is exactly what we did for the men's sandals. And then when you add the two up, that will give you the total time needed to fulfill the demand for women's sandals. And again, we will repeat the same procedure for children's sandals. So the first term is the time required on the machine to make the product or to fulfill the demand. Plus, not only do we require time to make the product, we also require time to set up the machine to make the product. And again, you'll repeat the same thing. So basically 120,000 was the demand, 0.02 hours is the processing time. So this is the amount of time needed to make children's sandals, plus this is the amount of time needed to set up the machine to make the children's sandals. So again, demand divided by the lot size will give you number of setups needed for children's sandals times how much time is needed for each setup. So then we add all of them up, and this numerator on the top, this whole thing, gives us the total time needed to fulfill the demand to fulfill demand for product A, which is men's sandals, plus product B, which is women's sandals, plus product C, which is children's sandals. So this takes care of our numerator. Now what is left is our denominator. So let me again change the color for explanation, and let's pick green. Okay. So now what we have to worry about is how do we find out the denominator? Now again, for that, I will go to our whiteboard. Here we are. Let me add a new slide. Can I add a new slide? Insert. New slide. And this into a blank slide. Perfect. Okay. And blue is fine. Yep. Okay. So what we have just found out is the total time needed to fulfill the demand, right? Now what we are trying to estimate is how, excuse me, I thought it was selected. Okay. Now what we are trying to find out is how much time do we have for a single machine. Now, how do we do that? I'll go back here and I'll just quickly flip back to our previous slide. Now, it says over here that the plant operates for 2 8-hour shifts, which means 2 times 8, 5 days a week, and 50 weeks per year. So basically, if we have one machine is run for 8 hours a day. Oh, sorry, 8 hours a shift. There are 2 shifts. So basically 16 hours a day times 5 days a week. So 2 times 8 is 16 hours, 5 days a week times 50 weeks per year times 50. And these will be the number of hours we have available for a single machine. So basically 5 times 2 is 10. So 500 times 8 is 4,000. This should be 4,000 hours. 4,000 hours, right? These are the number of hours we have available from one machine. And just to be on the safe side, let me verify this. So 8 times 2 is, we know, is 16. I don't need a calculator for that. Times 5 times 50 equals 4,000 hours, right? Now, as we did in our previous example, these are the number of hours that are available if we continuously run the machine. Now, we know that basically we have to keep some kind of a cushion because there are demand fluctuations, or we have to keep some time for eventualities like breakdowns or maintenance, etc., etc., right? So in this example, if I go back to the slide, it said the cushion is 5%. So in other words, we have to take 5% of the time away from these 4,000 hours. So essentially the time available is 4,000 times, and we are taking 5% away, 1 minus 0.05, which essentially is 5%. So essentially what we'll do is we'll multiply 4,000 by 95%, because that is essentially what 1 minus 5% is. And I will need the help of a calculator for it. So times 0.95, and this comes out to be 3,800 hours. Now, what does this number represent? Now, this number represents the amount of hours we have from one machine, assuming we keep a cushion of 5%. Now, to answer the same question again, I'll go to the logic that we applied in our last problem, which is how many machines are needed. So in order to find out how many machines are needed, which in this course we are calling it M, we need to estimate the total time needed to fulfill the demand, right? For demand fulfillment divided by time from, or time available, or time from a single resource, which in this case is our machine. So in other words, this number will be 3,800, and this number will be the sum of the time for product A plus product B plus product C. So again, for that, we will go back to our slides, and again, this is 4,000, right? And I'll go to these numbers. And now, as you can see in the denominator, it's basically 4,000 times 1 minus 0.95. And then, okay, so maybe I should remove this. Actually, you can see this in your slides, because in your slides, this annotation is not there. But essentially what happens is that when you add the time up for product A plus B plus C, it comes out to be 14,567 hours. And divided by 3,800, the number comes out to be 3.83. And as we said, since you can't have 3.83 machines, you will end up buying 4 machines. Or actually, you need 4 machines. Let me correct my statement. You will need 4 machines to fulfill the demand. Now that takes care of our first step of the 4 steps. Now the second step actually is identify gaps. Now we just now in the last slide we found out that we need 4 machines to fulfill the demand. Now then the question said that if you already have 2 machines, how many additional machines do you need, right? So which is pretty straightforward. If we need 4 machines and we have 2 machines already, basically we need to buy 2 new machines. So basically 2 more machines should be purchased unless management decides to use short-term options to fill the gap, which I would not recommend. In essence, you need 2 machines. Now, which is exactly what we discussed when we went through the 4 steps. As I said, the first step is estimate how many machines do we need. So we estimated that we need 4 machines. Then step 2 is estimate how much capacity or how many more machines would you need. So in total, we need 4 machines. Since you already have 2, so we need to buy 2 machines. Then step 3 are your ISDS issues of decision trees. Okay, why is my pen is acting up a little bit. Decision trees, etc., etc. And then step 4 is your finance calculations of NPV and IRRs, etc., 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 etc. So this, in essence, takes care of our 4-step process. The first 2 steps we have gone through in this chapter, and as I said earlier, step 3 and step 4. Hopefully, you will be taking up those things in your ISDS and your finance courses, respectively. So this, in essence, brings us to an end of our discussion on this chapter. In this chapter, in the start, as I said in our previous part, my previous video, we discussed the notion of long-term capacity. And then we went on to identifying a 4-step approach in which we discussed the first 2 steps in this chapter. So for this chapter, I've assigned roughly 8 pages from the book. Basically, those pages contain the same information that we have in the slides and that we have discussed in this lecture. There are a couple of extra pages that I have assigned as self-study, which are from these 8 pages. And as I said earlier, whenever something is assigned as a self-study, it means that I expect you to go through it. It will add to your knowledge, but there will be no questions in the exam from these pages, right? I've also assigned, or I'm also suggesting, some end of chapter problems, quite a few of them actually. Some of them are already there in your assignment as well. Going through these chapter problems on your own will help you prepare for the exam. Again, I have not finalized the exam yet. As I did say in my previous video, the times are odd. So, I mean, let me think about the exam a little bit more. But one thing that I would definitely say is that it would be, I mean, considering the circumstances, the exam would not be as challenging as it was in the past. Anyway, so with that said, I will go through this video one more time to see if, I mean, just to have a general feeling that I've done a reasonably okay job in terms of explaining the concepts. If not, then I might have to do another run. I did do a couple of runs before. I was not happy with them. But anyway, yeah, so I'll upload it, go through it, and let me know if you have any questions. I'll talk to you soon. Take care.